starting up the second, and I said I'll disseminate this to you somehow, whether it's on iTunes that UB does, or via just YouTube. So we'll talk about geographic attributes, a different type of attributes a little bit, and then wrap up until in 2 weeks. So in the vector, and we're talking about vector-based data. GIS vector data has the ability to store what we call attributes. And this is what makes GIS so unique. GIS is not just a map, but a data warehouse of information. Each feature on GIS has information behind it, which are called attributes. This is certainly a map. I mean, nobody would disagree with me probably. But let's say I wanted to know, the population of Germany. Can I touch the map or start asking them, what's the population of Germany? It doesn't have information behind it. It's just a picture. On the other side of that coin, you have software that is only attributes. I could have a spreadsheet in Microsoft Excel that has countries of Europe and their population, but I can't see them. I might see a row in the Excel that says Germany, 25 million or whatever it happens to be, but I can't see Germany. So you have GIS is the combination of combining a map and geometry with attributes behind it. And that allows us to do all the things that we do with GIS, that ability. There are even computer software packages that don't necessarily have the attribute capability of GIS. Is there any AutoCAD or MicroStation users here? There's a couple. And they've gotten better over there, but AutoCAD is more of a picture. They've added more attributes as time goes on than GIS is. You use AutoCAD for drafting a building or as-built, or a plan for a new highway, new building, and so on. But it doesn't have all the capability of storing all these attributes like GIS does, where we can do all this analysis. So in this general example, this isn't just a shape. It's and I should have picked one that I could pronounce. I don't know how to pronounce that. It's a county in West Virginia, where Charleston, West Virginia is. So where if this were AutoCAD, this is a paper map, all you would see was the shape. The GIS has attributes behind it. And whoever created this data set, the data set that you see is a map of counties in the United States, defined what attributes would be stored behind it. There's not very many here. It just has the name of the county and a key. But the person that creates the GIS data set defines when they first create it what attributes it'll have. So if we have an attribute, and I know UB uses GIS for this, an attribute of rooms. What can you think of some attributes behind, say, this room that you might store in a GIS layer of rooms of UB? What would be an example of some attributes? Yeah. Temperature. Temperature, that's a good one. It's a bit better than outside tonight. that could certainly be an attribute, and one that has that fourth dimension because it's going to change over time.
The number of desks.
Yep, excellent. Yep, number of desks. When planning, obviously UB needs to know that if 75 people sign up or 175 people sign up for this class, they need a different room. So that's a very important attribute. Any others? Yep, another important one. You would actually, if we tried to cram 175 people into the class, we're violating the law because there's an occupancy that's posted. There's a real basic one. I'll get, yep.
I was going to say, like, whether or not it has a projector, the board size.
Yep, all of those things, yes, yes, and yes. What about just the name of the room? Fillmore 355. I mean, that's a basic attribute also that would be important. So I think you guys get it. You came up with some good attributes describing this room. You could add more attributes describing this county. Population, square area, the county seat, Charleston. Demographic information about the demographic makeup of the people there. You get the idea. Those are all attributes behind GIS data. And the additional point I wanted to make with that exercise is that it's really up to you when you're defining data. And when we were just defining data, sometimes it makes a good test question too. you all came up with some pretty important things about this room. So there's no room data yet, so when whoever would first create this data would do what we just did. Would kind of sit down and brainstorm and think about, okay, what about the room is important? And then they put those things into the database as attributes. Questions? If you think about, you guys, you hit on most of these. There's different types of attributes. And this is an excellent question in some form or another. I'll always ask. We can, in the most generic sense, break it down into numeric and non-numeric data. Non-numeric data, the most basic type of non-numeric data is nominative or qualitative data. The name of the room. Fillmore 355 is an example of nominative data about this room. There's no mathematical value. It's a type of attribute used to describe the feature. Erie County, New York State, Germany, etc. Those are nominative attributes. If you think of attributes about you, your name is the easiest nominative attribute. If you think about how you describe yourself, if you introduce yourself to someone, hey, my name is so-and-so, that's a nominative attribute. There's no, like Torsten's name starts with a T and my name starts with a G. He's not somehow greater or less than me because it's a different letter. There's no mathematical value to the name of a person. This one we didn't hit. It's still non-numeric, but it would be categorizing the features into a set of ranges that are non-numeric. And that's called ordinal data. The best example for that would be a quality rating. So we didn't think of that for the room, but I've been at UB long enough, this probably would be very useful. Some rooms are better than others. So you might categorize the room into poor, mediocre, excellent. A good room's been renovated, there's enough chairs, we don't have a problem there. Or maybe the projector system is better than others in some rooms. So a group going through UB might rate the rooms. There's still no numeric category, but we are grouping rooms into categories. Does that make sense? We did that. We helped map that for Fort Hood Army Base in Texas, where for every building, the Army categorizes the state of the building in three colors, red, yellow, they call amber, and green. And they have black, which means run out of the room yelling. And it's funny, I was doing a training on this at Fort Hood. Oh, let's look at our building. Of course, it came up black. And so that was kind of a humorous moment. In their specific case, it's the largest Army installation in the United States. A lot of it was built for World War II. The room I was teaching with was built for World War II and hadn't really been updated since World War II. So hence the property appraisers of the U.S. Army gave it a black rating, which is the absolute worst. Buildings that are brand new that have been renovated get a green. So you can think of how there's not a numeric value, but they've taken buildings and they've grouped them into, I think I'm getting ahead of myself. Yeah, it's on a slide in a minute. I do that. They group each building into these four ranges based on whatever. Based on, is the size of the building appropriate for its use? Is it falling apart or has it been renovated? So on. That's ordinal data. It's still non-numeric, but unlike name, which is just naming things, you're grouping things into these non-numeric categories. In red, green, yellow, good, moderate, poor, those are examples of ordinal attributes. Make sense? Questions? Numeric attribute data is, as you might not be too surprising, it represents numbers. But I should mention, just because an attribute's a number doesn't mean it's numeric. You can have, this is going to sound weird, a non-numeric number. And a non-numeric number is a number that has no mathematical meaning. And the example I always go to write is zip code. A zip code is a number used, obviously the Postal Service uses to deliver mail in the United States. Every country has a zip code of a sort. But there's no math behind 14260 is UB zip code. The Zip code I live in is 14004. UB isn't somehow better or greater than my zip code because it's a higher number. There's no mathematical value to the zip code. So even though it's a number, it falls into the higher category. Social Security number would be another example. Everyone here that's a United States citizen has a Social Security card with a random number that's been assigned to you. There's no mathematical value to that either. It's a random number. So just because it's a number doesn't mean it's numeric. Does that make sense?
Would that be like those zones from earlier?
Yeah, the
Or
only
do those kind of have,
red, green, like the.
no, like we're on the 17th or 18th.
Well, that's a great point. Exactly. Yeah. Yes, that's a very. I've never thought of that. No, but you're absolutely right. I love that. Maybe that'll be a good bonus. For those of you who weren't here, sometimes to reward people that attend, although you guys are pretty good, you're all here. I'll throw out a question and ask it on the test on something specific like that. When I took a class back in the 90s from an environmental science professor, that was my major. He just, the day before the test, he wrote, Duff's has the best chicken wings in Buffalo. And people asked him, why? And he wouldn't answer. And then the test came, and it was a question, who has the best chicken wings in Buffalo? And then the people that raised their hand complaining, oh, you weren't here, were you? I like that a lot, because it's something I hadn't thought of, but you're exactly right. Those zones have no mathematical value. It's just a random number. Like zone 18 isn't better than zone 17 somehow. It's just a different number. You don't like subtract zone 18 from zone 13. It doesn't make any sense.
Well,
So
17 is better than 18 because that's where we are.
that is true.
Okay.
So you're right about that part. But there's no mathematical value to the number. So you're absolutely right about that. That's a real good example. I'll have to remember to use that next year. So numeric, differing from that, numeric is an attribute that does have a mathematical side to it. And we have interval and ratio. Ratio is the easy one. We'll get that out of the way. Anything that can be added to or subtracted and multiplied is a ratio value. And to do that, it has to have a real 0 point. So if this room has an occupancy limit of 100 and Knox 20 has an occupancy limit of 500, can I say that Knox 20 can hold 5 times as many people as this room? I can. 500 students is 5 times as many students as 100. That's ratio numeric data. There's all sorts of examples of that. Population, median income, occupancy, and so on. The exception to that is interval data, and someone mentioned, I'm glad someone mentioned temperature. Temperature, when we talk about the room, temperature is interval numeric data. It doesn't, we're not talking about Kelvin here, we're talking about Fahrenheit or Celsius. It doesn't have a real 0. If you think about it, 0 degrees Fahrenheit, which we're probably going to be close to when we leave, is an arbitrary number. Or even 0 degrees Celsius is an arbitrary number. It's sort of smart, they made it the freezing point. But you can have negative temperature. So it's numeric in that I can say, if we all fly to Miami tonight, it's 75. 75 is warmer than 10. There's more degrees, there's more heat in the air, more kinetic energy, it's been too long scientific physics, than 10. You can't dispute that. But can I say, let's say it's 10 right now. I think there is a one front coming, so it might not be that cold when we go out. Let's say it rises from 10 to 20 by the time we leave. Is it twice as hot? It's still pretty cold. But it's not twice as hot. I had a student really arguing this last year. And that's because 0 is arbitrary. I asked the student, and most people will get this, let's say it's 1 degree tonight, and it warms to 2. Would anyone say that it's twice as hot? You can't say that because the 0 is not an absolute 0. It's certainly not twice as hot when it's 2 than it is at 1. In other words, now, if it's 80, it would have to go to 160 to be twice. So do you understand? And then, okay, so if that, let's say you go from -3, what's twice as hot as -3? Is it -6? Is it 3? I mean, you can't really make that comparison. Now, if it's Kelvin, you can, because Kelvin has an absolute 0 value. So there was the argument we got into last year about this. Does that make sense? And I can really, maybe since you guys are on tonight with some cool examples, but maybe someone can think of a different example. I can't right now. The best example for interval data is temperature, and I really can't think of anything else off the top of my head. Temperature really describes interval data well, and I can't offhand think of another example. So obviously I wouldn't ask something like that if I can't think of it myself. But do you understand the difference? Why? The difference between interval? I might ask on a test, describe the difference between interval and ratio. I'm not going to ask for an example, but that's hard now. Yes?
What do you think about GPA scores? As an example,
Maybe.
Is that considered interval?
There's still, that's a tough one, because you wouldn't say, there is
Well,
a...
scores on a test.
Yeah, no, I like that. That brings up a good debate, because it's a hybrid almost. There is an absolute 0. I mean, you could get an F in every class and get a 0. You can't get a negative GPA, can you? Hopefully not. And it's kind of like if your GPA was 0.25 and somehow they let you stay at school and you got up to 0.5, would you go around saying, well, I did twice as well this semester? You might not. So in essence, I can see your point. You could make that case, but it might still fall into ratio because there is an absolute 0. The absolute worst you could do is 0. You can't get a GPA of -1. A test score would work if I don't do. Although someone was telling me in my class last night, they have a professor that he asks true/false questions, and it's almost like a hockey overtime or something. If you get it right, you get 1 point. If you don't answer the question, you get 0. But if you answer it wrong, you get -1. That's really mean. I'm not sure what class that is. So was it?
The SATs.
Well, SATs could be like that too. Yeah. So in his class, he's grading his test such that he doesn't want you to guess, and he wants you, if you don't know, to not answer. In that case, there's no absolute 0 because you could do worse than 0 on his test. You could get everything wrong and then answer true false is incorrect and get like a -10. So that would be an interval because of the way that he grades. But I think in a normal grading situation it would be ratio because there's an absolute worst. Like on my I don't do that. So on my test, if you come in on February 24th, just hand me a blank sheet of paper, you'll get a 0. That's the absolute worst you can do. You can't do any worse than 0. So if one of you gets 50, I don't know, one will, and one of you gets 100, you could say that the person got 100 got twice as many points as the person that got a 50, because it all comes back to this base point of 0, the absolute worst that you can do. Does that help? That's a good question. Yes.
Like, let's say you're ranking, like, I don't know, I guess restaurants, like,
Yeah.
by like first place, second place, third place. Would that be ordinal, or would that be a numeric type of?
I would say ordinal. Let me think about that a minute, because you're grouping them into categories that aren't numeric.
Right.
Even though you're saying first, second, or third.
Yeah.
Does everyone agree with that? And you can see where that's a little different. That's ordinal, in my opinion. It sounds like you agree, even though you're using numbers. Because it's not really a number in that case. Whereas temperature is a number, even though you can't relate it back to 0. You can say, 75 is warmer than 10. You just can't relate it in a ratio. You could even say it's 65 degrees warmer than 10. But you can't say it's twice as hot or so on. Cool. Any other comments? I like that this slide always elicits commentary, which I like. That's good. And it's always good to hear these new examples that I hadn't thought of before. So any questions? I wouldn't ask interval, but I might ask for examples of this one's too hard, or be too easy, just put temperature. But I might ask for an example of one of the other three, or ways in which they differ from each other. And I've kind of got ahead of myself. Here's some slides for your reference that explain some some examples of each. This is from the ESRI sample data showing time zones in the United States, so that's nominative. Yeah, sorry.
Is population density considered an interval or ratio?
I would say ratio because it goes to 0. You can't have,
Like a negative population?
yeah, you can't have a negative population density. And there is an absolute. That's another good question. Let's think about that. But I would say it's ratio in that particular case for that reason.
How about like money? Like what if you owe somebody money?
Yeah, I guess you could say it's interval because your bank account could be negative.
Yeah.
That's weird. That's a weird example, which I like. Because you could say, I have $4,000 and then I went to the casino and made $4,000. So now I have $8,000. I think you would agree you do have twice as much money. Or even you could have a penny and say, someone gives you 2 pennies. So now you have 3 pennies, you have 3 times as much money. I almost want to say it's ratio, even though you could have negative balance. That's an interesting one. See, I like that too. Would you agree that it has the components of ratio, even though your bank account could be negative, but there's still an absolute 0 of no money? Yeah, I think so. Do you agree, or that's a tough one?
Yeah.
Even though there's a potential of a negative in that case. Another good one.
In that case, though, aren't you looking at 2 different variables?
Yeah, because you're looking.
Amount of money versus your bank balance, and your bank balance would be interval.
That's a good way to rectify it. You can't have, even though your balance could be negative, you can't have negative money. If you think about it, you don't go into your wallet and pull out a negative $5 bill. Sometimes it feels, allegedly you can't. Sometimes it feels like that. Even though your bank balance could be negative 5, there's no such thing. That's a really good way to clarify that. There's no such thing as a negative $5 bill. But there is a such thing as negative 5 degrees, which we might have experienced last night. So that's a good way to clarify that, and that's why it's kind of 2 different things, and it would fall under ratio. Does that help explain?
Yeah.
That's a good. These are all good questions. So in this example of nominative or named data, it's simply the 7 time zones of the United States. There's 4 time zones in the continental U.S., and we have Alaska and Hawaii. What's in Atlantic? Oh, Puerto Rico. I didn't know that. Puerto Rico is far enough east that it's in the Atlantic. I didn't know that. But if you think about it, it's far enough east of Florida there, which you're an hour ahead. And then Arizona is weird. They don't do daylight savings time, which is always confusing, I think. So this is a nominative data set. Think about it. These are names that describe the names of the time zones: Eastern, Central, Mountain, and so on. See, I knew this is the Fort Hood thing I was talking about. I realized as I was saying, oh wait, I have a slide about this in a couple minutes. These are buildings on post. You don't say on base, I get in trouble. A base is a Navy base. An Army is a post. Have been scolded about that because Army and Navy have to hate each other for some unknown reason. So I've been scolded a couple times. So it's an Army post, not an Army base.
Is that a bonus question also?
That might be. You guys are also doing good with the bonus. We have the Army Navy, we have the UTM zones. We referenced the 100th meridian last week to the tragically hip. We've got all sorts of last. You missed that. And
That sucks.
yeah, it is the 100th meridian is the 100 degrees west. And now you know what meridian is. That one almost certainly will be the one that I ask. 'Cause I like that one. But what does the what group wrote about the 100th degree, 100 degrees west longitude? It'll be the tragically hip. But if anyone calls that classic rock, you'll lose points.
What is it then?
Modern, right? That's current.
Oh, okay.
That's not too old, right? Super current. Thank you. So I guess you can get negative points on the test now. So I said you can't, but sounds like 15 years old, but we're not going to talk about that. So here's where we've grouped in colors. These buildings are rated with ordinal data. These buildings were given, and this is real data, an excellent rating. It's hard to tell. This building was given amber, which is in the middle. For whatever reason, those buildings were rated as poor. So that's an ordinal category. Oops, and I didn't advance. There it is on the video. Interval, obviously, we talked about is temperature. Numeric attributes that cannot be expressed as a ratio. I think we talked about that enough. And that's certainly not from today. Look at that. 50 something? And then ratio, which many attributes fall into, are zero base attributes. We often represent them with a range of colors. We are going to get into this a lot more, I think, in the second period. There's 3 components of the class. I'm going to call them periods or trimester. The second of the third section, 3 sections of the class. We'll talk about different color strategies for these different types of data. And we'll talk about how, since numeric attributes fall into a range, we draw with a range of colors, like light yellow, dark yellow, orange, and so on. But since nominator data, we often use random colors because there's no mathematical comparison. And we'll talk about strategies of specific colors. And I actually wanted to, this is a new thing. I'm going to ask you something about these maps that I have. And this will be kind of a preview of what we'll talk about in the cartography. And there's a cartography class, on cartography, which is another cool class if you haven't taken it. Open with Photoshop. No, I don't need to do that. Wow. I just want to open a bitmap. And this will hopefully illustrate why color choice is important on a map, assuming it ever opens. What state is that? Why'd you say Ohio? Everyone said Ohio. I didn't hear a single person name another state. They're all red. Why? But what made you decide that I was asking about Ohio? It's different and it's darker. People's eyes immediately go to the darker thing. Every single one of you said Ohio. Well, I probably, to illustrate the point better, I could have made New Mexico a lighter color or something. But everyone still would have said Ohio. We'll talk a lot about that. That went well. I'm happy about that. And one more example. And notice I purposely didn't say what is the dark state, or I just said what state is that, and you all knew what I meant. Every single one of you. And when we talk about that more, we'll talk about cultural norms in mapping. This is a map of risk. I'm making this up. Risk of radiation contamination in the United States by state. Where is the risk of contamination in the United States the worst? Everyone will say, why do you think it's the Northeast? It's darker and no, I'm completely making this up. But it's red. People will often associate, and that was a lot of people said that, but it's not necessarily 100%. People associate red with bad. I mean, look at traffic lights. Red means stop, green means go. You're good to go when the traffic light turns green. So we'll talk a lot more. There's other cultural norms and things to consider when you're choosing colors on a map that we'll get into. And you don't have to worry, I made that up. But I wanted to make it something that was bad to drive home. And hopefully everyone agrees radiation poisoning is bad. And to drive home the point of bad and red. But that that could be completely a Western culture thing, and people from other cultures might not make that association. if I go back to my temperature map, I said I wouldn't get into this yet. We have a whole class on this. Where is it cold? Or I'd say North Dakota, because it's blue. In Eskimo culture, like Alaska and northern Canada, they have the opposite perception. Because blue ice, the ice turns blue, I may not be describing this when it's warmer. So to them, they represent warm colors with blue. And they think of red as a cold color. So it really is a cultural difference, where in most other cultures we associate red with hot. And I'll stop before we'll talk a lot more about these things probably in March, when it'll be redder or warmer. So any questions? So in other words, color is important. Darkness of color is important. But the thing to take away now before we get into more detail is that for nominative data, we'll use random colors. Because we're not evaluating the Eastern time zone versus the Central time zone. We're just using the colors to differentiate them. So usually we use random colors. That's the important takeaway so far at this point in the class. With ordinal data, you would use a ranking and of cultural norms, like green. Just like a traffic light, we chose green for good and red for bad. You might confuse people if you made good green. If I did a chemical contamination map and the places that are safe are red and the areas that are really dangerous are green, you might confuse people, even if there's a legend. I saw a map from the last U.S. election that had areas that Barack Obama won in red and areas that Mitt Romney won in blue, where most people, and this is a new phenomenon, think of blue as Democrat and red as as red states and blue states, for those of you that are in this country. That's recent. That has only been in place since 2000. That's a very new thing, and it was started by a Buffalonian, Tim Russert, who's passed away, started the term red state, blue state only as recent as 2000. So they've gone back and updated older maps, but if you look at older election maps, oftentimes they're reversed and really confusing. That was my question. I'm not going to do that again. Last year, that was the question: who started the red state, blue state? It was Tim Russert.
What was his role again? I'm like blanking.
He
out.
was a political commentator on NBC, I think, like on the
Right.
Sunday
Oh,
show.
yeah.
And he's a proud Buffalo. Unfortunately, he's passed away in a heart
Yeah,
attack.
just recently, right?
Yeah, just a couple of years ago. And he was a proud Buffalonian, like he'd bring in a Buffalo Bills mug and stuff like that to show off. So that's a cultural norm that's relatively new. Any questions? And I said that's an introduction. We'll talk about these different symbol and color selections later in the course in more depth. And the cartography and visualization course in the geography department spends the entire course talking about these things. And that's another really interesting course. Questions? How are we doing? 8:38. We'll do good. We will switch gears a little bit. I said this introductory course we're going to cover, rather than go in depth on one thing, we're going to cover a lot of different topics. This topic is related to vector data. It's called GIS topology. And here's some lengthy definitions I pasted. To describe it in a nutshell, it's a way to model how different geometry of different features relate to each other. When you have different layers or different features within the same layer, what is their spatial relationship or their relationship in space? What room is next to Fillmore 355? I think it's 357 right there. And the class is in there too. That room is next to this room, if you think about that. Everyone would agree with that. That's a spatial relationship between the two rooms. And that can be modeled with something called topology in the vector data model. So you can set up rules using topology to say, if I'm drawing classrooms, there can't be a space in between. This room and that room must be adjacent. That's something called a topology rule. We'll have a bunch of examples in a minute that'll help clarify this, hopefully. All of you, there's another analysis, and I showed this really briefly last week called point and polygon, and now I'm going to talk about it in more depth. All of you, you probably agree, are inside this room. That's a topological relationship. That person walking by out there is not inside the room. That sounds simple, but I think it's a good, simple example of explaining how two features relate to each other spatially. The first feature being you, the second feature is the room. You are inside the room. And there's a gazillion different environmental and real world ways where that relationship is relevant. So other examples. What is connected to what? Do these roads connect? Do these shapes overlap? There's a good example. If these shapes are states, states can't overlap. You're either in one state or not. There's no point in the United States where you're in New York and you're in Pennsylvania. States aren't defined that way. So if you're drawing a GIS layer of states, you can set up a topology rule so that if you happen to draw a state on top of another state, that's an error because it violates your rule. Property parcels have that. Obviously, your house, if you live at home, or your parents' house is on their property. It's only on their property. Like, there's not area near the edge of your property that overlaps your neighbors and you share it. That's a topological rule when they're drawing property boundaries. They cannot overlap. Points can connect to lines too. I've done a lot of work at Erie County Water. I've been there 21 years. And they have a GIS layer of water mains, which is one-dimensional, right, of a line. And they have a zero-dimensional point layer of hydrants. Well, the hydrant better connect to the water main, or it's not really useful. You don't just put a hydrant in some random place, and then the fireman comes along and hopes that water is going to come out of it. Or every line has to have an ending on it, whether it's a hydrant or a cap, or the water would just flow out of it. So those are two topological rules between lines and points. The point has to touch a line. The hydrant has to be placed on a line. That's a topological rule. Or every line has to have a point at its end. Either another main or hydrant or a cap that blocks it. Otherwise all the water would just flow out into the world. Does that make sense? So another more topology examples. Making sense so far? So when we set up a GIS topology, we define which data layers participate in the topology. So here, if my GIS data set has water mains and hydrants, those two participate. If I have another layer of trees, that does not participate. The trees don't have any specific defined relationship with water mains. They might be near it, but there's not this grouping of this specific topological relationship that the water main and the hydrant has. Make sense? Yeah. So this example, this is from property mapping. This person has selected 4 GIS layers that participate in this topology, that they have this relationship. And it's, parcel polygons, parcel lines, road center lines, and block lines. The entire neighborhood might be one block. And within the neighborhood, if there's 10 houses in your block, you might have 10 properties within one block, without getting too specific into what that means. So in GIS, and I don't think we have a lab on this. I wish we did. There's just not enough time to cover everything. You can set up rules, and these are screenshots from ArcGIS. So in this example, this person has set up a rule that an area must not overlap another area from the same layer. And the states or counties or countries example is a good example of that. A state can never overlap another state. And with topology, at least in ArcGIS software, you can have it flag that as an error. You can take existing data to define a topology. I just did this today. And then look for things where there's a problem. Someone may have accidentally done this. I mean, everyone knows to not draw Pennsylvania on top of New York. But what if you pick up Pennsylvania and move it by accident? Or you just draw a little bit further than you want to. This happens all the time. Topology is a good way to look for these accidents that happen when you're creating the data. So another type example, and there's many, I just pick out some to help illustrate the point of what topology is. An area feature in one layer must be contained within a feature from another layer. That's a little bit more complex. So let's think of towns or counties. Erie County must fall completely within a state. You know, Erie County is wholly part of New York State. It doesn't spill into Ontario or Pennsylvania. So you could model that relationship as well. To say, you know, if I'm drawing counties, I can't draw it outside the state. It has to fall completely within the state. Make sense? So there's an example, another example of a topological rule. And you can flag that in error, say if you do draw a county outside the boundary of New York State or outside the boundary of the United States. Or areas from one layer must contain at least one point. That's a little like it's not an area, it's a line, a little like my example here with the line has to contain a point on it, the water main. And here's some examples of lines, and this is sometimes a good question to ask you to come up with your own example of a topology. A line must not intersect or can't overlap another line. So if this is a road, there can't be a stream at the same spot. Hopefully not. I mean, that wouldn't make sense. So that's a rule you can set up that involves lines. I think it's another good example of the line is this main line must contain a point. And that's what I have here. Endpoints of lines from one layer must be covered by a point feature. So the line must have a hydrant on the end of it or some other type of valve. Here's an example of a linear topology. And then some point topological rules as examples. We have property parcels. So say this is your property. There's your house inside it. Another way we map properties is something called a centroid. On a property map, every parcel has a centroid, which has the easting and northing of the person's property, the X and Y. Every parcel has to have a centroid is a rule when you're mapping parcels. Centroid actually is, we'll talk about this more, is the weighted center of an area. There's another definition of centroid beyond this, just as an FY that we'll get to. So the centroid, let's say New York State, is the gravitational center. Say if you had a New York State shaped tray at a restaurant and you wanted to balance it on your finger, the centroid would be the weighted average center of New York State. So that's another meaning of the term centroid, if you haven't heard that before. I've never related it to a tray at a restaurant before, but hopefully that makes it. You can tell I didn't have dinner. Any questions so far? And GIS software often has tools for locating topological errors. I mean, we're not going to really get into that in the course other than describe its existence. So this is a screenshot from ArcGIS showing where this is a block of property parcels. And it's centroid. So this is someone's property and there's their centroid. I accidentally removed this person's property and notice that it flagged that as an error Because in this data set, I'd set up a topology that properties can't overlap. So by moving that by accident, now I'm violating that rule, and you see the red there. Additionally, here I accidentally moved the centroid for that property outside of the polygon, so that also generated an error because I had set that up as a rule. So those two things are errors. I should note that you can, in any good topology, and as ArcGIS has this, you can set up what's called an exception. Another cliche, I said I wouldn't use cliches, but every good rule has an exception. So GIS should be able to model that. What if this is true? And there are real world situations where people's property overlaps. If you have a timeshare, a condo in Florida or something, you actually own that condo for that week that you go down to Florida. That other family that comes after you owns it for that week. So if every family owns the condo for 1 week, oh bless you, there actually are 52 overlapping properties, you think about it, in that case. That's an exception. So any good topology has the ability to mark something as an exception. Maybe there is a county that's not in a state. I don't know. Any questions? We're getting near the end. 8:50. So one other, I hinted about that metaphysical fourth dimension, and this slide kind of introduced that. The fourth dimension in GIS would be time. So you have point is the 0 dimension, length is the first dimension, area is the second dimension, the 3D area is the third dimension. The fourth dimension models change over time. This is a screenshot of change in population. Look how much we're losing here, which has nothing to do with the weather. So the fourth dimension is measuring over time. And very often in GIS, that's the question. Think about it. Many maps are the answer to a question. Some maps are just reference, but that's still an answer to a question. How do I get somewhere? Any map that you create is answering someone's question. And often the question is, what has changed? So you're making a map that compares what things are like now to what they used to be like. And this map does this. This map measures change in population for each U.S. state from 2000 to 2007. You can see the southward shift. This would look very different, I think, from 2007 to now. Because some of these boom states crashed in 2008, like Nevada. Everyone's leaving Las Vegas and California and so on. So that's measuring a change over time. It's measuring that fourth dimension. One recent article, Buffalo was in the top 10 hot real estate markets. I read that and I was a little bit shocked if you're from here. It was one of the 10 most lucrative real estate markets in this survey in the United States. It was Buffalo.
Because it's cheap.
Because it's cheap, yeah. All the
And all the development on water.
Exactly. I'm from Buffalo, so I saw that. I looked for a pig to go by after I read that article. I said, what? And it was all places. It was Buffalo was in it, Rochester, Cleveland. It's like, what? It's exactly that. All the people from these areas that crashed are looking for places that they can rent a little cheaper. I mean, I saw houses, I took ESRI classes in Southern California, I saw little tiny houses that were $1.5 million for like 1,000 foot square house. That's not sustainable. And in 2008, we found that out the hard way. So all those people suddenly looked at a Buffalo, it's like, yeah, the winter stinks, but I can get a house for $100,000. Maybe it's not so bad. And that's why the real estate market is actually strong here. And we're also not based on these are boom economies. 50 years ago, to buy a house for $100,000. Now you can buy a house for $100,000. 50 years from now, it'll still be $100,000. No one's getting rich off real estate, but it's consistent. And myself, I'll take that over this $1 million. So I was surprised to see that. Another time attribute. This is from one of Esri's, mapping from one of their training classes. This is mapping things over years, but here we're mapping the track of a hurricane. For each one of these things may represent, 12 hours as the hurricane moves northward. Another example of mapping that fourth dimension, change over time. Well, in this case, the change over time just a couple of days, not 10 years. And ESRI has a specific extension called Tracking Analyst that helps you map over time and even helps you build movies where you can kind of play and you'll see. I should animate this. You can see the hurricane moving. Oh, and that's it. We're a little early. Is there any questions before we stop? Again, I'll send out an email reminder, but there's no need to show up a week from now, but I will record a session. And just to be complete, I'll review what's in the session on the evening of the 17th for a brief time. And have a good night. We'll see you in a few weeks.